Hello my friends, welcome to my channel Math and Stuff by Samson Paul. Um, I hope you're all doing good, and I'll be taking one more topic today. In this second video, the topic would be integration by finishing the squares. It's often in some textbooks also called as completing the squares. It's one and the same. Okay, so finishing or completing the squares. Okay, so for this you need to know a few algebraic identities, that is a plus b whole square equal to a square plus 2ab plus b square, and a minus b whole square is equal to a square minus 2ab plus b square. These two identities you should know, and in the future videos I will probably tell you how to use this equation. And one more other maybe integration formula, that is integral of dx x square plus a square is equal to 1 by a tan inverse x plus x by a plus c. Okay, so this is very important to know, and that is the reason I have taken this formula, because if you use this formula you can avoid a lot of trigonometric substitution. If you use the formula you can avoid lot trigonometric substitution, and the whole process will become simpler. Now if you look at the problem here, it's a very simple problem to start with. It's nothing but integration of dx by root of x square plus 2x plus 5, and I normally tell my students use a method where you compare 2x with 2ab. Okay, and you have to complete this square, a square plus 2ab plus b square. Now if there was a minus sign here, you would be using this formula, the formula that is being highlighted right now. And since there is no minus sign, you for sure know that it is x square plus 2ab plus b square. Okay, now 2ab equal to 2x, so you basically mark 2ab is equal to 2x, and you say a is equal to x, okay, and b is equal to 1. So for sure now you know that your a as well as b, so you can just write it as x square plus 2x plus 1. Okay, and basically it's always I say students, you can either write 5 as 4 plus 1 and take the 1, but an easier method to avoid some kind of confusion or error is that just add 1 and subtract 1 to the overall equation, then add the 5 term. Okay, so that's what is done here. It's x square plus 2x plus 1 minus 1 plus 5, and that is nothing but a square plus 2ab plus b square, and that gives me x plus 1 whole square, which is nothing but the formula. Okay, and when I do this, the formula remains, and it is getting converted into x plus 1 whole square, and the minus 4 plus 1 will give me nothing but 4. Alright, and I can express that as integration of dx x plus 1 plus 2 square. Okay, and dx will be x plus 1 whole square plus 2 square, where x plus 1 is compared with the x here and the 2 is compared with the a, and that's how you get the formula 1 by 2 tan inverse x plus 1 by a plus c. Now I want to indicate one important stuff here, that this formula works if there is no coefficient attached with x. This formula would not work if you have 2x plus 1. Instead of x plus 1, if you had 2x plus 1, this formula would not work. There's a particular method on how to solve this, but this method basically works only if you don't have a coefficient with x. Okay, so a lot of times my student asks me what happens if you have 2x plus 3 or 5x plus 4. All these are the possibilities, and this method will not, this formula will not work unless and until you modify, unless and until you modify something. Okay, I'll teach you basically any method, any problem you have, how to get it into this basic form, and that is very easy. Okay, let us consider another example shown here. It is dx divided by 2x square plus 8x plus 20, and you have, in place of previously you had no coefficient here, but now you have 2 here, and here you have 8x, okay, plus 20. Now this is a very simple example, and I have chosen this example purposely so that it's a lot easier for you. Okay, it's a lot easier for you to understand. And what I normally tell my students is just divide the entire equation by the coefficient that is present with respect to x square. So the coefficient that is present with respect to x square is 2, and when you divide it by 2 you get a 2 here, and it becomes x square. 8x by 2 is 4x, and 20 by 2 is 10. Alright, and the entire problem is transformed, that 1 by 2 comes in the denominator, so this is 1 by 2 integration of dx x square plus 4x plus 10. Okay, now as I said, to complete the square in this case you have to compare 2ab with respect to 4x. Okay, now you know your 2x, now your x is already transformed from 2x to x, so there is no need to take a as 2x. Okay, you could probably use that method, but if you use that method you may not be able to use the formula which I showed you. Okay, so if you're using this formula, make sure you use this method. Okay, that you're making it a is equal to xb plus 2. Okay, and that becomes half of integration of dx x square plus 4x plus 4, which is a perfect square, x plus 1 x plus 2 whole square, and minus 4 plus 6, that will give me a 10. 6 minus 4 plus 10 will give me a 6, and 6 can be expressed as root 6 whole square. Okay, and that's what I have done here. Okay, now in this, when you compare with the previous formula, you get, I'm sorry, I have made a mistake here, you get 1 by 2 root 6. Okay, 1 by 2 which is not integrated, and 1 by a. 1 by a is nothing but root 6, so 1 by 2 root 6. Okay, and you can simplify, you can take the 2 inside and do all kinds of stuff, but you can also just keep it like that, 1 by 2 root 6. Okay, and 1 by 2 root 6 by root 6. Okay, by root 6 tan inverse x plus a divided by a plus c, so root 6. Okay, then here also you get the formula by root 6. Okay, the final answer will be nothing but 1 by 2 root 6 tan inverse x plus 6 x plus root 6 by root 6 plus c1, that is x plus a by a plus c1. So this is a standard procedure I tell my students to use to make the entire trigonometric substitution much simpler. Alright, and you can see the constant of integration has changed from c2. I have introduced a new constant c1 that can be done because it is an arbitrary constant. Its value depends on boundary conditions. Okay, so you might be wondering why I have started this channel just by some random videos from integration, and methods are coming out of nowhere. So based on the response of these two videos, I'm planning to start the entire integration or the differentiation chapter before that, to video by video to explain every step, and I would make it into a tutorial to make you guys understand the entire process of differentiation and integration. So give me some time, I will process those things, maybe based on how many, maybe if I get 20 views on this, I would do that. Okay, so I hope you enjoyed the video, and I hope you enjoy mathematics too. I wish you good luck. Bye.